All right, we are doing leak code 1717, maximum score from removing substrings. Given a string, two integers, so a string and two integers. You perform two types of operations anytimes. Remove a substring to gain x points. Remove substring to gain y points. Okay, it's always a, b, and ba. Okay, interesting. Return the maximum points you can gain after applying the above operations. Okay, so is this a greedy problem or is this a DP problem? Always want to move BA first. Yeah, BA. And then you want to move AB. Doesn't matter which ones you remove first or second. Wait. I guess sometimes. So you remove the BA here. And then what if you remove the BA here first? Does it even matter? All right, let's just. I think my intuition's not exactly sure, so let's kind of go through this problem and greedily remove the ABs here because the ABs are more. All right, let's just see what happens here. So we'll remove this AB, and then we'll remove this AB, and then we'll remove this AB, and oh my gosh, I'm not counting. Whoops. Okay, wait. Let's restart here. Okay. We'll do them each lines. Okay, so 1, 2, 3, 4. And that's 5 times 4, so that's 20. And then let's do a greedy on this, and then if that's the case, I think we're going to go with the greedy solution. I don't really see how you can do this in terms of any other way. So in this case, the BA is more expensive, so you want to remove BA. So that BA gets us 5. We'll remove that BA. That BA, so that's 5, 10, 15. And then, yeah, remove this. That makes sense because you always. So you're going to want to greedily search for BA. If not, then search for AB. Okay. Cool. So we could come up with the sort of easy solution is this. We'll code it up really quick. Okay, so while s dot find of AB does not equal -1, or and s dot find of right, it's find, yeah, I think it is, does not equal -1. Find is an O of n operation, so we're saying while those don't exist, yeah, this is not perfect, but we're gonna be slow here. Let's stop find of again AB, or yeah, so x end and we'll have a y end here. So that lets you know what the indice at which the value is. Oh, we're just returning the points. The result. I'm actually thinking about not even removing values here. It's tough though. I'm wondering if you can kind of just even just search through the list. Because if you see a B, and then another B, is it a stack of some? We'll see. Okay, so you find them. I'm thinking you might want to do a stack here because this is getting a little complex already. Because then you have to find it, remove it from the array, from the string. If you find AB, which we would find here, right? Like, we'd have to then remove it. I see. So I'm thinking a stack of some sort. So we would just have this stored, and then maybe not a stack, but if there's a BA at any point, remove it from the stack, and then add the value, corresponding value. Then if the last two values are BA again, add it to this, remove it from the stack. If it's the case that there are no BAs ever, that means there's only A or B, or there's AA, BAs. And in that case, you would just want to do a iteration. Okay, so that kind of doesn't make sense. That probably is really confusing, but essentially I'm thinking about building a stack, right? And anytime you see a, for this example, if it was, let's just pretend this is always 4 and 5. If this, since y is 5, if it's ever BA, delete it. And then that could create a ripple effect. Right? So like if it's if you have A B and then you see a C, right? I'm thinking about going over the list twice. So if you have A B and then you see a C, that means you never saw a B A, but you might see a. You would have to loop over it again and say, "Do you see A B?" Okay, so let's create a stack. for I in range of S. So, or we'll just do set with the top. Yeah, we could just always flip the lines. I always love that command. What is it? Option, yeah, option up arrow. Okay, so for I in range of N, right? If S of I equals B or A, or so if S of let's just focus on this case, pretending that Y is always greater. So if that if the stack B, if it A, it's a weird one. If we had this, you would see a B here, remove it, and then you have another AB. Sometimes you don't want to remove the. So in this case, right, you never find a BA. So you keep looping through till you find a BA. And then maybe when you come back, you see A. Hmm. This approach won't work. Okay. The stack is weird. It's like I don't know if it's monotonic stack or whatever it's called, but the solution here is so simple in terms of the way I can think about it. But in terms of like actually coming up with that solution, it's tough. Oh, what if we had a counter? What if we counted all the BAs? No. Let's see here. So B, B, B. No, it would be B, B, A, A, A. And then it's like valid parentheses almost. This would get deleted. And then this would get deleted. B, A, B. This would get deleted. And then go through here. Go through the list again. And then if you ever see an A, B, remove it. Okay. If stack, and let's just try this. And this is kind of what I was going for before. Stack and stack of -1 equals, we're just going to pretend it's the first case, equals B, and S of I equals A. Stack dot pop. Right, and then res equals 0. So we pop the last one. Okay. If A, B, and then should it be a while? Because what if you see like, we're gonna stack out append. Okay. Uh, okay. If S of I equals B, or S of I equals A, stack dot append S of I. So we'll always add it to the list, and then if the stack of 1 if the lattice stack is greater than 1 and stack of 1 equals B and stack of, this work -2. I don't even know if that works. Hopefully it does. Get the 8th value. So this should be while. And then it will kind of just delete all those. We'll stack that pop. Both of them, actually. And then res plus equals, for this, it's just going to be y. We'll come back to making it so it works with both. Okay. So then that works. So if we return res here, right, it should give us 15 or something. 10. Let's see. We get BA and then BA, and then it should be 15. Let's see what we got here. That's not gonna work. Interesting how it still. Really? 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Sorry, this should be, that's really dumb of me. It should be A and B. I'm backwards on that. That's my fault. First, put the hand up. Okay, now we're getting 20. Why is that wrong? Okay, let's see. Um, B A 6. Go. I'm close here, but I'm struggling a little bit. I'm struggling a little bit here. What are we at? 21 minutes? Plenty of time. Okay. Um, BA 1, 2, 3, 4, 5, 6. So we remove that one. And then we remove that one. Oh, I see. Then it's removing. Got it. Okay. Okay. Else, we need to check for ABs here. Um, yeah. So the else, for now, we could just set stack equal to 0. That's... What if it's A, A, B? Yeah, for now, that's going to fix it, but it's not perfect. Yeah. That's an edge case we need to think about. We're going to come back to that one later. So, but it will be solved what we do now. So now we have, let's print out what the stack looks like at the end. So that's essentially saying, hey, we were adding this B to the back, and so this B and this A were getting locked. So now we have AB. So I think we want to do something very similar here. Except, wait, I think we want to do pretty much this. So we loop through each value, and then if we ever see that, if we ever see BA, right? We loop through each value, but if we ever see I, which is 1, I minus 1. No, it's not exactly right. You want to, we want to go through the stack, not N, right? And so if we're looking for the AB, AB, what do you have AA, BA, or AA, BB, right? That's the case you have to look for. So if you see Hmm. BI. Edge case after edge case. What if we did the logic here? Like, if you have A, what if you have, what if you have BA? That means you removed it. You see two A's. That means that BA would already be deleted. But what if it was, okay, if S of I equals A and stack of -1 equals I, we can just skip that value, I think. No, no, we can't skip it. Because it could be A, B, B, B. The thing is, we have two priorities like in the way. It's messing me up. What if we treated it like this? You know what I mean? Like, because it's like the same problem, right? What's the difference? For each value in the stack, let's just create a new stack, I guess. New stack. If new stack of -1 equals B and new stack of, I'm trying to think of this kind of whatever way. -2 equals A. New stack dot pop, right? And then stack to the pen. And we know it's going to be A or B, so we can just append them. And obviously we have that edge case that we haven't dealt with here yet. Actually, the edge case would probably call this function. Yeah. And we'd add X here. new stack. And yeah, res is going to be plus x. Oh my gosh, new stack. Dot append. I keep forgetting these small things. On 31 minutes? Okay. So now we get AB. Okay. This is almost perfect. So now for I, well, the lattice stack. So we new stack appends S of I, which is going to be A. Oh, it's got to be the reversed. Oh, it does it? New stack is B. Really, you're not. Oh, stack. Really, is this. What's the issue here? We're going through each value in the stack, so it would be A. We append A to S of I. Sorry, not S of I. It would be stack of I. Whoopsies. Whoopsies. Okay. This should get this case correct. Yeah. Perfect. So now we're passing that case. Essentially, this code where we check for the ABs, we want to call here. So we'll create a function for this. We'll call it, well, it's very similar to the other function, what we just wrote, but def clear AB. I mean, this is only accounting for when x equals 4 and y equals 5. Clear less points, I guess. I don't really know. Okay. We have clear less. So, yeah. If there's a stack, we'll call clear less points. And this will return, put a final, which is going to equal that, and the final will be here. Return final. We'll also set val here, and that will be that. So in this case, this would be x. And then if stack, we call clear less points x. And then we'll move this up here. Kind of not the best logic at the moment, but essentially what we're doing here is we're checking, we go through the BA check and then the AB check. So pretty think decently well to understand. We're on 34 minutes. That's okay. There's optimizations in terms of the BA, AB stuff, but we'll do that in a minute. Does everything still pass? We have to pass in stack here. It's gotta be stack. Sorry, stack needs to be passed in here. Stack. Stack. Okay. We're getting the wrong value because x equals To reset the stack, that's right. Okay, now we get AB, perfect. We get final, and then res plus equals. Perfect. Okay. So now that's passing that test case. Okay, great. So we're passing the when x and y is that. So now we just have to make sure that this essentially needs a conditional check. And this needs a conditional check to say okay. Yeah, essentially here we're going to do greater. It's hard to, so essentially what I want to do here is I want to set this value to a conditional. So if y is greater, then we want to set it to a particular way. And then, so we essentially want to say a conditional on the y, on if this value is great. I'll just write it out, and I think it will make more sense. So last will equal y, last will equal a if y is greater than x, else b. So we're keeping it what it is right now. So last, and then this will be second last, which is b and a here. So it's just kind of conditionally checking. So, and x and y never change. That's just so it makes it easier to do this kind of logic for each value, because sometimes x is greater, y is greater, and yeah, so we're getting the right answer technically here. We're getting 16, 20. We're just adding y 4 times. We're doing 4 times y. We should be doing 4 times 5. Hopefully that was clear enough. I don't know if I was. Sometimes when I get in the zone, I don't necessarily communicate well enough, and I'm trying to work on that. So now we're switching these. Let's see here. Let's see, so we put this to last, and we have to obviously switch that because now we're looking at the not as valuable array of values. Let me send that. We're still getting 16. Interesting. Oh, because this here and this. Oh gosh. Okay. X if y is greater than x, else y. So we want to throw in x to the less. We want to throw in x because it's the less point calculation, and y if it's the less. And then here we'll do plus y if y is greater than x, else x. I hope that's right, or like syntactically that's right. Yeah, okay. That's good. Let's submit it. Okay, really large numbers here. Which is kind of annoying. Only passing 7 test cases. What? Okay. Uh, so in this case, y is definitely the winner. Okay, so um, greedily, I'm gonna take out this BA. And then we have this AB. So I like what you see in there. Then remove this BA, and then there's nothing there. This is wrong too. I don't know if that's the reason why, but that's that's one of the reasons why we're wrong, but I don't think that's this reason per se. We're passing one more test case. Are we missing a solution here? Looks like we're missing one. Looks like we get to use this test case. So I would remove this ABA. We get 9,000. Then we get 13,000. Then we get like plus 9. What's the answer? 23. So, oh, it's essentially 10,000. Okay, so we get 10,000, 14,000, 24,000. That would be it right there. That's what I see. So we see this AB here. Looks like we're not seeing this BA. We see B, 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 B. Wait, what are we getting into here? Print. Are we getting in here? We get 9. Why? Oh my gosh. Forgot to add res plus equals there. That was a diabolical question. I think we're slower because the prints here. I mean, there's definitely ways to improve the solution. It's super, super slow, but that's it. Yeah. There's another print here. I don't think it matters though. So yeah, essentially we loop over twice. I wonder if there's anyone who's come up with one loop solution. I bet you there is because I'm pretty slow here. Two kinds of greedy methods. Look at these. I never understand these like so complex ones, but Hopefully that makes sense. I don't think my thought process was clean enough on this solution. I kind of thought about it a little too much. Yeah, so they are doing a second pass and a first pass. Um, and yeah, I mean, actually pretty similar here to what I had. You know, um, see how they dealt with the picking. Yeah, they did. If x is greater than y, they rewrote it. Actually, it's not that great. I kind of did the same thing. Yeah. Okay. Well, that's it. Thank you guys for watching. It was a pretty longer one. Hopefully my thought process was not clear enough, but I hope you enjoyed watching anyways. So yeah.